Other freshwater ecosystems are lakes and ponds. These are standing ecosystems. They're broken down into 3 different zones, and it has to do with where they are and light intensity. So you have your littoral zone, which is the shallow water that's along the shore. Limnetic, which is out in the open water, and it has high light penetration, or has light penetration here. And then your profundal zone, which is kind of like the benthos, or that we looked at earlier, which is the down below, where it has no light, all right, and it's below the limnetic zone. See here with a typical types of animals and plants that you find in your lakes and ponds. Different types of turtles, frogs, amphibians, snails, different types of insects, fish, invertebrates, worms, other types of fish, and then phytoplankton here. And where they are distributed, depending on the different zones, like limnetic zone, profundal, benthic, or littoral, which is here at the shore. You have different types of lakes, like oleotrophic, which some of you saw this word on the practice exam, which is the opposite of, eutrophic. And these areas tend to have high, let me write this up, increase oxygen concentration. Reason because you tend not to have as much nutrients in plankton. You have steep drop-offs, very low organic material buildup down below, narrow littoral zones, little shore vegetation. And these are some key things that you'll see with an oleotrophic lake. And then fish also tend to swim all the way throughout, and they'll be down at the bottom, not just at the top. And then you have your eutrophic. All right, eutrophic tend to have low quantities of O2. And what you'll see with the eutrophic lake is wide littoral zones. All right, so there's this wide area. You tend to have high concentrations of nutrients and plankton, dense fish populations in your limnetic zone, lot of shore vegetation, right? We tend to have eutrophic lakes here in Florida and southern states, you do. And oleotrophic tends to be more in northern states and areas. Oh, and also sandy, and silt, and clay bottom, and the sloping shorelines. All right, so it doesn't have that drop off as you do with oleotrophic. And there is also a human-induced eutrophication that we've talked about so far, but I want to re-go over it, because you can have a oleotrophic and turn it into a eutrophic. And that tends to happen when you get nutrient runoff, like you read with that agricultural runoff in dead zones after chapter 6. You get that nutrient runoff, and in increased nutrients, you get increased phytoplankton. Increased phytoplankton, you get increased bacteria growth. That increased bacteria growth, you suck all the oxygen out of your, here I'm going to draw it here, all of the O2 goes away, all right? So here, O2 is present. With no O2, you get fish kills. Fish tend to not accumulate, and then with that phytoplankton and bacteria growth, as they live and die, they start to build up sediment at the bottom. So here you can see an oleotrophic lake, very healthy. This guy's got a Cichlids here, looking at turbidity, which is the clarity of water. So this turbidity would be low, this turbidity would be high, because it's not very clear. Which one do you want to swim in? Yeah, this stuff. No, you want to swim in this, right? Nice clean lake. You can have changes inside of your lakes with different types of temperature stratification and turnover periods within a lake. Thermal stratification, this is where you have your changes in temperature and how they sharply change with depth. I don't know if you've ever swam in a lake. If you can notice at the top it's very warm, and then down below tends to be much cooler. Well, that temperature change, depending on where you live, can be altered by the seasons, just the time of the year. You also have this thing called a thermocline, which is the seasonality distribution of temperature and oxygen that affects the distribution of fish in a lake. You can have this fall turnover, which falling temperatures in autumn cause a mixing of layer of water or lake water. And then also the spring turnover, which occurs when the ice melts and the surface water reaches a 4 degrees Celsius again, which is above the freezing point. And then blooms. And blooms are those increase of algae and bacteria. And that turnovers can cause convection currents, bringing nutrients up, causing blooms. We can see here with the different types of turnovers and then what it looks like in fall and summer. You have high concentrations of oxygen. You have your high concentration of oxygen with the darker and lower concentrations with the lighter. So you can see here in the summer tend to have lower concentrations of oxygen down below, higher above. Same here with the winter. But it tends to, actually no, if you look at this, you can see that the medium concentration is here at the top, and the winter and the high concentrations right here in the middle. Or in the summer, the high concentrations at the top and the mediums very small. And then with the fall turnover, you get that mixing of those different types of concentrations of oxygen that can bring nutrients up and cause